Good morning, ladies and gentlemen. Today we're going to continue with chemical equations, and today we're going to be covering how to balance an equation. What does it mean to balance an equation? Well, that means that what you started with in the beginning, if we think about it in terms of parts, the different elements, so let's say carbon, oxygen, so on and so forth, the total amount of it that you have in the beginning should be the same as what you have at the end. All a chemical reaction is a transformation. You're rearranging the way the molecules are put together, but you should have the same amount in the beginning and the end. Okay, it starts us off with the bike as an example. A bike is made out of different parts. Okay, in this case, you have the frame, you have the wheels, you have the handlebar, and you have the pedals. Okay, in the beginning, we have one frame. So therefore, when we put our bike together, there should only be one frame. When they're separated, we have two wheels. And then when you put the bike together, you should still only have two wheels, and you do, okay? We have one handlebar in the beginning, and we have one handlebar at the end. You have two pedals in the beginning, and you should have two pedals at the end, okay? So this is what I mean by making sure that what you have in the beginning should be the same as what you have at the end. So separated, these are all the parts. You put them together, you have a bike. But if you count all the parts on the bike, it should be the same as when they were separated. Okay? Hope that makes some sense. So here we're getting to our first actual chemical reaction, okay, or the chemical equation, and let's balance it, okay? So the first thing you should do when you're trying to balance an equation is keep track of how many of each thing you have. Okay, let's do that. I recommend you set up a little table. So right, I'm doing right now is I'm separating the chemicals from the accounting underneath. Okay, so what you're doing is you're trying to count how many of everything they have. So on the left side, remember the left side is your reactants. In the reactants, right now we have one carbon, we have four hydrogens, and we have two oxygens, O2. On the right, we have one carbon. We have three total oxygens, two from the carbon dioxide and one from the water. And you have two hydrogens, okay? So this is not balanced. Right now, this chemical equation is not balanced, okay? We have more hydrogens on the left than we do on the right. And we have more oxygens on the right than we do on the left. So now we need to balance this. And how do we begin to do that? Okay. In front of every chemical is what we call a coefficient. If you do not see a number there, you assume it's 1. So right now, there's an imaginary 1 in every single front of these chemicals. We have one of everything. But when you have one of everything, it's not balanced, okay? The recipe is incomplete. Now we need the right proportions, okay? So you think about it like a recipe. You might have all the ingredients you need, but you might not have enough of one, okay? So maybe you need more of one than you do another. The recipe is not proportional, okay? We need to fix it. So the only thing you're allowed to play with, the only thing you're allowed to play with when balancing a chemical equation is the coefficient, okay? You can mess around with how many of each chemical you have. You cannot edit the chemicals. What do I mean by that? So right now this is O2, right? So one oxygen molecule gives me two pieces of oxygen because it's O2. They're together. So I have one of them, so I have two oxygens. If I made this a 3, I have three O2s. Now suddenly I have 6 oxygens. I'm allowed to change the coefficient, okay? I'm allowed to change this number. You are not allowed to change any of the subscripts. So that subscript 2, you can't touch that. That subscript 4, can't touch that, okay? That subscript 2 on the water, you can't touch that. So you cannot edit those numbers. The only thing you are allowed to edit is the coefficient in front, okay? So let's continue and see what they end up doing. So in the beginning, we have more oxygens on the right than we do on the left. So we need more oxygens on the left. So what do? We add another oxygen molecule. So now we have two O2s on the left, and now we have 4. And they also added a second water. Okay, so now that we added a second water, now let's count how many of everything we have. So now on the left, we have one carbon, one carbon. Carbons are balanced. Check. You have 4 hydrogens on the left. You have 4 hydrogens on the right. Check. Hydrogens are balanced. We have 4 oxygens on the left, and we now have 2 plus 2. Now you have 4 oxygens on the right. Okay, so now everything is balanced. You have 1 carbon on each side, 4 hydrogens on each side, and 4 oxygens on each side. Now everything is balanced. This is a balanced chemical equation. Okay. So balancing is just about accounting, just checking, okay, how many of these do I have on the left, and adding more until they're equal, okay? So now let's get into some vocab, okay? So the subscripts are the little numbers here that I was just mentioning earlier, okay? They tell you how many of that element you have in that chemical, okay? So in CH4, there are 4 hydrogens, okay? Remember, CH4 is methane. Okay, this is methane gas. That's what this is. Wow, that's horrendous. Well, the label doesn't matter. Okay. These are your subscripts. They tell you how many of each of that element you have in the chemical. Okay. So here is methane, and they have the little diagram of each. So in methane, there's 1 carbon, which is the black ball, and 4 hydrogens, which are the green balls. In O2, you have 2 oxygen atoms. There you go. In carbon dioxide, you have 1 carbon and 2 oxygen. And in water, you have 1 oxygen and 2 hydrogens. Okay, so they have it shown each, but that's what the subscripts represent. The coefficients tell you how many of each of that chemical that you have. Okay, so let's look at oxygen here, for example. The subscript 2 tells us that in 1 oxygen molecule, there's 2 oxygen atoms. And we have 2 of them. And that would be the entire thing. So in one of them, there's 2 oxygens, and we have 2 of them. So we have 4 oxygens total. Okay, so that's the difference between subscript and the coefficient. Okay. Now let's look at another example. Okay, so this is what I recommend for you when you're solving these: is make a little table and keep track of how many of each chemical you have on each side. So in the beginning, we have H2Cl2, and this makes HCl. Okay, so if you're counting in the beginning, let's look in the beginning. We have 1 of everything right now. If we have 1 of everything in the beginning, we have 2 hydrogens on the left. Cool. And we have 2 chlorines on the left. Cool. You make HCl. If we have 1 HCl, then you only have 1 hydrogen and 1 chlorine on the right now. So what do we need to do? We need to add a second HCl. The product side is the side that is lacking, so we need to add more to that side. So if we add a second HCl, now we have 2 hydrogens and 2 chlorines on the right. Now you're good to go. Now everything is balanced, and you are done with the problem. They also give you a little demonstration. They have a little diagram with a little balance beam. I have something similar for you to play around with in the simulation. Okay, but this is another example. I don't like this example too much. It isn't. I want to start from scratch with one of these. Okay. So let's move on. Which of the following is the correct molecular formula for carbon dioxide? Okay, so this is a little bit of a review. Okay, carbon dioxide, di means 2, so there should be 2 oxygens. For molecular formulas, if you don't see a prefix in front, I'm sorry, if you don't see a prefix, Jesus, I can't speak today. If you don't see a prefix in front of the first element, that means that you only have 1 of it. Okay, remember, you don't use the prefix mono for molecular formulas. So carbon dioxide should be CO2. This should be A. Okay, that's just a little bit of review. Okay, now here is more of what we're doing. To balance the chemical equation, what is the coefficient that we need in front of the carbon dioxide? Okay, so in order to do that, let's see how many of each we have on both sides right now. So first thing you should do, so here's the setup I think that works the best for this. So split the left side and the right side in half. Cool. Write down all the elements that you see. Okay. So there's carbon, there's hydrogen, and there's oxygen. Those are the three elements that we have here. Okay. Same thing over here. You have carbon, you have hydrogen, you have oxygen. Okay. How many carbons do we have right now on the left? Okay. We have one of, remember, if you don't see a number, you assume you have one of it. Okay, so we have one of these, C6H12O6. So in one of them, there are 6 carbons. So we have 6 carbons here. We have 12 hydrogens. We have 6 oxygens from this chemical, and then you get 12 from here. So 12, 6 times 2 is 12. That's where the 12 comes from. 12 from here plus the 6 here is 18. So on the left side right now, we have 6 carbons, 12 hydrogens, and 18 oxygens. Let's look at the right. If we pretend this is a 1, pretend there's an imaginary 1 there. Okay, there's an imaginary 1. So if there's a 1 there, that means right now we have 1 carbon. We have 12 hydrogens. And we right now have 6 plus, right now we have 8 oxygens. Okay. So what are we lacking? We are missing carbons, and we are also missing oxygens, okay? There are more carbons on the left than there are on the right, and there are more oxygen on the left than there are on the right. So we need more carbons and oxygens. And what gives that to us? CO2. That's why the problem is asking us to edit the coefficient in front of the CO2. So now when we only have one chemical to edit or one number to change. So with a problem like this, you can get away with just looking at one of the elements. What do I mean by that? So each CO2 molecule is going to give me how many carbons? Each CO2 is only going to give me 1 carbon. I need 6 of them. So what number should be here? 6. If you make that edit, now what are our new numbers? If I make this a 6, now instead of 1 carbon, we now have 6 carbons. And instead of just 8 oxygens, now we have 6 plus 12 gives us 18. So now by making this a 6, everything is balanced. 6 carbons, 12, 12, 18, 18. Okay, so the answer here would be D. That's how I want you to go through these problems. The best way I think to do it is to set up a table, count how many of each you have, and adjust until you get it to be balanced. Basically, it's like guess and check. Okay, that's really all you can do here. Okay. Balancing, there is no magic trick, there is no equation. It's just you gotta play around with the knobs. You have to add more of each of something until you get it to where there's the same on each side. So here we have another example. Chlorine and sodium bromide make bromine and sodium chloride, aka table salt. Where they want us to balance this equation, they're going to use the technique I just showed you. Okay? So you have this set up. Boom. Set up a table, splitting the equation in half. Okay? You have the left side, you have the right side. Left side reactants, right side products. Right now, how many of each element do we have? Well, what are all the elements we have? We have chlorine on the left, bromine, and sodium. And it should be the same on both sides. Chlorine, sodium, and bromine. On the left, we have 2 chlorines, we have 1 sodium, we have 1 bromine. On the right, we only have 1 chlorine, we have 1 sodium, and 2 bromines. Okay? So the sodiums are balanced. Sodiums are balanced already. What's not balanced is there's the chlorine and the bromine. That's what's not balanced. So that's what we need to edit. Okay? So we need to play around with these numbers. Within the numbers I'm talking about are the coefficients. The coefficients are what we can edit. So we need to play around with the coefficients. So what do they do first? We need more chlorines on the right. Okay. So what they say is identify the side that needs more of a particular element. Where are we right now? Okay. So we need more chlorines on the right. What gives us the chlorines? What gives us the chlorines is the NaCl. If this is where the chlorines are coming from, this is the number we need to change. So if we want a second chlorine, what do we need to do? We need to put a 2 here. And what happens when we do that? Let's scroll down and find out. Okay, going. Boom. So they add a second sodium chloride. And when you do that, now you have 2 of everything on the right side. Now everything becomes 2, 2, 2. Okay, now we have 2 of everything. So now the sodiums are no longer balanced. So now we need to look at the left side. So we have 2, 2, 2, and 2, 1, 1. So now we're lacking sodium and bromine on the left. And where does that come from? That comes from here. So now, what do you think we should do next? Well, we need a second one of these. So we need to put a 2 here. And what happens when we put that 2 there? Scroll down and find out. And now we have 2, 2, 2 on the left and 2, 2, 2 on the right. Okay? And now this equation is officially balanced. Okay? So that's all balancing is. It's just glorified accounting. That's all you're doing is accounting. It's checking and making sure that all the numbers add up to be the same on both sides. That's all you're doing. That's all you're doing. Can be easier said than done for some, but that's the idea. So the concept isn't anything crazy. It's just checking. We're at the 17-minute mark, so I'm gonna go through some practice problems and call it a day. Are these some good examples? These are some good examples. So that's the same question, that's the same question, that's the same question. So let's do one of these and I'll go to the sheet. Okay, they're all asking you basically to balance the equation. Balance, balance. Yes, they're all asking you to balance the equation. So I'll do one of these and then I'll go to the worksheet. Okay. So let's do number 6 here as an example. When the following equation is balanced, what are all the coefficients? Okay. Step 1, separate both sides, make a table of elements. What are our elements? We have Hg, and then we have O. Hg, and we have O. With one of everything right now, how many Hg's on the left? 1. How many oxygens on the left? 1. How many Hg's on the right? 1. How many oxygens on the right? This is O2, so you have 2. So what are we lacking? We are lacking an oxygen on the left. So in order to make the oxygens balanced, I need to put a 2 here. But you can't pick and choose what you get more of. So I need a second oxygen. And the only way for me to do that on the left side is to get another whole HgO. So now instead of 1 of everything, now I have 2 HgOs and I have 2 oxygens. So by balancing one thing, sometimes you mess up another, okay? That's when you get to the more complicated equations and can take some time. So our Hg's were originally balanced. They're not balanced anymore, so now I need to balance them. I have more Hg's on my left than I do on my right. So now I need to add another Hg on the right. And Hg on the right is completely separate. I can add individual ones because it's by itself. So I need a second Hg. When I do that, now I have 2 Hg's on the right. And now I have 2, 2, 2, 2. Everything is balanced. So when this equation is balanced, what are the coefficients? The coefficients are 2, 2, 1. So this is C. Okay, now let's get to today's sheet. And I'm going to do number 1 and number 2. Well, I'm going to do number 1 only just because there's really no blank spots for me to work with here. I'm going to try to make this as neat as possible because I do need space to do these. Okay, so we have Z and S plus HCl gives you, I'm rewriting it out just because I need the white space underneath to go through it with you. ZnCl2, yep, plus, yeah, this is not, oh well, it's all good, H2S. Okay. Step 1, separate the problem, left side, right side. So what are the elements we're working with? We're working with zinc, so Zn. We are working with sulfur. We are working with hydrogen. And we are working with chlorine. So Zn, S, H, and Cl. That's what we're working with today. How many on the left do we have? We have 1 zinc, 1 sulfur, 1 hydrogen, 1 chlorine. On the right, we have 1 zinc, 1 sulfur, we have 2 hydrogens, and we have 2 chlorines. Okay? Matter of fact, I'm going to do this instead. I'll leave that there, but I'm just going to be using, because it's not neat enough. I'm not happy with that. I'm just going to edit the equation that they have here. Okay? So right now we have 1 of everything on the left. We have basically 1 of everything on the right, except the hydrogen and the chlorine. So we need more hydrogens and chlorines on the left. Where do we get those from? Hydrogen and chlorine on the left comes from the HCl. So in this case, we can kill 2 birds with 1 stone. Each HCl gives you 1 of each. We need 1 more of each, in fact. So we just make this a 2. If we make this a 2, now we have 2 hydrogens and 2 chlorines on the left side. And with that, we're done. Balanced. 1 zinc, 1 zinc, 1 sulfur, 1 sulfur, 2 hydrogens, and 2 chlorines on each side. So this is balanced. So for number 1, the only thing you need to add is make that a 2, and the rest of these are fine as 1s. That's a short one, so I'll do 1 more with you, in fact. Okay? I'll do 1 more with you, because that was a short one. But hopefully you guys are getting the idea. Let's do one that looks weird. Well, not too weird. I don't want to make this video too long. Let's look at number 5, because number 5 looks kind of complicated. So in number 5, we are working with number 5 here. Number 5, we have sodium. So Na. We have sulfur. We have oxygen. We have iodine. So those are the 4 elements we're working with. Assuming we have 1 of everything, what does this look like right now? 2, 2, 3, 2. 2, 2, 3, 2. So this is 2, 2, 3, 2. On the right, we have 3 total. we have, that's a 4, correct? Let me zoom in real quick on that. That is a 4, right? That is indeed a 4. That is a 6, correct? Yes, 2, 4, 6, 1. Should be a 4, this should be a 6, and this should be a 1. Not an I. Okay. So we are missing some sodiums on the left, some sulfurs on the left, some oxygen, and iodine. Where do we get all of these from? All of these come from the same place. They all come from the Na2S2O3. So because I need more of them, I need a second one. I have to add a second one. If I add a second one, what are my new numbers? This now becomes 4. Let me change colors here. So instead of 2 of these, now we have 4. Same thing here, and now we have 4. Now we have 6, and this is still the same. Okay, so these are our new numbers after we added the second one. Now where are we? Now what's lacking? Now what's lacking on the right now, we need one more sodium on the right, and we need one more iodine on the right. On the right side, where do we get those from? We get those from here, NaI. Again, we're lucky we can kill 2 birds with 1 stone. So each chemical is going to give us 1 sodium and 1 iodine, and that's exactly what we need. We need 1 more of each. So let's make this a 2. If we make that a 2, instead of 3 here, this now becomes a 4. Instead of a 1 here, that now becomes a 2. And with that, I think everything's balanced now. 4, 4, 4, 4, 6, 6, 2, 2. And everything's balanced. Okay, so the rest of these would be 1s. And that's number 5. And that's how you balance equations, ladies and gentlemen. Okay, it's just about accounting and checking that you have the same number of each element on both sides. That's all balancing equations is. Okay. Yeah. Okay. I think that covers everything I want to talk about today. Okay. Thank you guys for your attention as always. Appreciate you. Hope you guys are doing okay. Best of luck with the material. And as always, if you have any questions, please feel free to reach out. Okay. Take care, guys.